Okay, so last time diniscuss natin yung concept ng phasors, right? Okay, at pinakita natin na phasors is another method or simpler method of at least solving a differential equation, a second-order differential equation that describes an electrical circuit. Okay, specifically yung RLC na circuit. Tama? Tama? Okay, so RLC tapos series na RLC circuit. So pinakita natin na ang concept ng phasors ay simply a translation ng sinusoidal wave to the Argand diagram. Pag sinabi Argand diagram, it's a diagram that describes the imaginary at saka real component ng wave na describe ng electrical circuit. Okay? So, ginamit natin yung phasors dun sa series na RLC circuit. Ngayon, titignan naman natin kung paano gamitin ito sa parallel na RLC circuit. Pero before that, may questions from last time? Clear ba yun? So, kung wala akong clear yung series na RLC circuit last time, then, discuss natin ngayon yung parallel RLC naman. Pag sinabing parallel RLC, lahat ng elements, lahat ng circuit elements, resistor, inductor, tsaka capacitor ay parallel sa isa't isa at parallel sila dun sa voltage source. Okay? Okay, so ganito yung itsura. Of course, in contrast dun sa discuss natin last time, naka-series siya, di ba? Ang common dun sa series na RLC circuit ay yung current. Tama? Okay. Tapos, ang tinry natin na i-solve dun is yung voltage across the circuit elements, di ba? At pati yung voltage across the source. At nakita natin na yung voltage across the source is not necessarily in phase with the current through the source. Meron ba kayo klase? Ha? Lab? Hinihintay niyo yung teacher niyo? Hindi ba kayo pwedeng pumasok na kasi ingay niyo eh. Tandaan niyo every Wednesday, Friday gagawin natin ito. Okay, kung hindi kayo tahimik, habang naghihintay, every Wednesday, Friday gagawin natin ito. Please lang, konti consideration. Sila yung maingay. Please lang, consideration. Sa mga late dyan. Walang nga kayo, gagalit ako dito. Pagpasok dito, tatawa kayo. Okay. Now, what is the difference? How do you compare this with the... Ako na, record lahat yun, ano? Pwede ko namang i-edit yung part. What is the difference of this RLC circuit kumpara sa series? Okay, kasi ang dinidescribe ko before tayo na-disturbo ay yung current is the same all throughout. Diba? At yung voltage yung nag-iiba sa bawat circuit elements. Right? Dito, ano naman ang okay, yung voltage yung pare-pareho. Right? At ina-expect natin na yung current through each circuit element ay mag-iiba. So in other words, yung voltages dito sa source, resistor, inductor, tsaka capacitor, they are all in phase. Okay? The same way na sa series RLC circuit, okay, lahat ng current ay in phase. Okay? So, hindi necessarily in phase yung current sa parallel na RLC circuit. So, it could be na yung current dito through the source is out of phase with the current through the resistor, the inductor, and the capacitor. Okay? Okay? Now, paano ba kayo nagsosolve ng RLC or ng parallel circuit sa 102. Ha? Nag-Kirchhoffs kayo, di ba? Naalala niyo na ba ang Kirchhoffs ninyo? Balita ko, nagre-refresh daw kayo sa 173 na laboratory, tama ba? Or at least yung iba. Hindi nyo ba, dun sa section Z ba yun? Hindi nyo pa ata nami-meet yung teacher, no? Pero yung section ZZ, nagre-refresh daw kayo, di ba? Ng inyong 102.1, tama ba? Na-refresh na ba kayo? So, in this case, okay, ang hinahanap natin dito ay yung total, ang isa sa mga pwede natin hanapin dito is yung total na current, okay, which means na yung current passing through the source, okay, at yung current passing through the source ay equal sa square, sa sum ng squares ng currents passing through each of the circuit elements. Okay? Okay? Now, in contrast dun sa sa Kirchhoff's rules, or pag DC yung source, straightforward yan na IS is equal to IR plus IL plus IC. Okay, for a DC source. Okay? Okay. So, since ang tawag dito, ang current through the inductor, okay, ay out of phase by 180 degrees with respect to the current through the capacitor, pwede nating i-rewrite yung IC as negative ng IL, okay, at yung magiging working equation natin ngayon, okay, which relates all the currents in the circuit elements is this. Okay, naintindihan niyo naman siguro kung paano nangyari yan. Okay, the same way sa series RLC, ang source voltage is the same as the square of the resistor voltage plus the difference between the inductor voltage at capacitor voltage square dun sa series RLC. Okay? Okay. And yung phase, okay, nung tawag dito nung total current, okay, nung total current dito sa source, okay, ito. Okay, ay pwede nyo makuha by taking the arctangent of the current through the inductor minus the current through the capacitor divided by the current through the resistor. Ayos? Ayos? Okay, dali. And tulad nung ginawa din natin before, we just use Ohm's law, ba? Straightforward na Ohm's law. The voltage across the resistor is just the product of the current through the resistor multiplied by the, anong tawag dito? Resistance. Yes. And the current voltage across the inductor ay equal sa product ng current through the inductor tapos multiplied by product ng current through the inductor at saka anong tawag dito sa X sub L? Inductive reactance. Okay? At yung dito naman, product ng IC at saka ng XC ay equal sa BC. Yung XC ay capacitive reactance. Okay. And dinefine din natin last time na yung capacitive or inductive reactance is just equal to J omega L. Okay, at yung capacitive reactance ay equal sa J omega, J times 1 over omega C. Ayos? Ayos? Okay. Now, we're going to use, okay, we're going to use a slightly different method pagdating sa parallel circuits. And mag-i-introduce tayo ng tawag dito, inverse ng capacitive reactance at ng inductive reactance. So first, let's begin with this equation. Okay, alam natin gamit Ohm's law na pwede natin isulat yung equation as this. Okay, makikita nyo na merong terms na reciprocal nung resistance, for example. So dito mayroon kang 1 over R squared, dito mayroon kang 1 over XL, dito mayroong 1 over XC. Okay, reciprocal ng capacitive reactance at capacitive inductive reactance. Okay. Okay, so since pare-pareho yung voltages, right? Kasi di ba sa parallel circuit, equal lahat ng voltages. So pwede natin i-factor out yung voltage. Tama? At ang matitira ay itong expression na ito. Okay? Sunod. Parang ano lang din, di ba? Parang sa 102, di ba? Na may reciprocal ka na. Okay, and then pwede nyo i-rewrite yan in terms of this. Now, we're going to define the reciprocal of these resistances tsaka reactances. First, yung reciprocal ng total reactance. Okay, ay tatawagin nating admittance. Okay, kasi, di ba, resistance, ano bang reciprocal niya? Siyempre, kung nire-resist, anong opposite nun? Pinapayagan, di ba? So, admittance. Okay? Of course, yung resistance, ang tawag lang natin sa reciprocal nun ay conductance. Okay, and then, yung reciprocal ng inductive reactance ay inductive susceptance. Okay, and then yung reciprocal ng tawag dito, inductive capacitive reactance ay capacitive susceptance. Okay, at makikita nyo rin dito yung corresponding na expression in terms of yung angular na frequency for the inductive susceptance at saka inductive capacitance. Capacitive susceptance. Naintindihan nyo kung bakit may negative sign dyan? Dito? Naintindihan nyo kung bakit may negative sign dyan? Di ba kasi ang ang XC is J over omega C, right? Okay, so ang reciprocal ng 1 over XCI, omega C over J, tama? Pero i-multiply nyo lang to by negative J, right? So yung denominator is just positive 1, okay, at ang 1 over XC is negative J omega C. Okay, so which is just equal to which is yung capacitive susceptance. Okay na? Okay na? Walang ano dito, walang bago, kundi yung mga terms lang in English yung bago dyan. Pero yung mathematics, yung concept is still practically the same. Ayos? Ayos? Okay. So now we can rewrite this equation from a reactance in terms of the reactances to this equation in terms of the admittances. Di ba mas madali yung treatment pag walang reciprocals? Tama? Tama? Or at least it seems na madali. Okay? So, walang questions? May klase ba kayo dito? Anong klase? 1. Bumalik na lang kayo ng 1. Okay, so mga physics yun, ano? See you next year. Okay. Okay, so dito tayo ito yung para sa okay, this is another way to represent anong tawag dito? Yung impedances. Okay, you can represent it as what is called an impedance triangle. Okay, well, it's nothing but a phasor lang din, di ba? Kasi yung total na impedance o yung Z, di ba? Yan yung Z, yan yung total na phasor, right? And then yung reactance, yung reactance is just the sum of the capacitive tsaka inductive reactance, di ba? Ito. So yung X na yan is just XL minus XC. And alam natin ang capacitive tsaka inductive reactance ay nandito sa imaginary na axis. Tama? So kaya nandito siya sa axis na ito. Okay? So if we draw an argand axis, ganyan, so yung reactance na yan is just this. So it's still a phasor. Okay? And yung resistance, alam natin na nasa real axis siya. Okay, so ganyan lang din siya. So walang bago dyan. Nire-represent lang natin yung phasors in terms of this, what is called an impedance triangle. Okay, now in terms of admittances, pwede rin natin silang i-represent in terms of, anong tawag dito? An admittance triangle. Pero in this case, okay, yung susceptance, yung sa capacitive at sa inductive na na susceptances ay pababa na. Okay, pababa. Okay, imbis na pataas. Okay, and then yung admittance, anong tawag dito? Yung conductance ay nandun pa rin sa real axis, pero nandun sa negative na part. Okay, so in this case, ang ating argand diagram will look like this. So ito pa yung positive axis. Okay, positive real axis, tsaka positive na imaginary axis. And then yung admittance, susceptance ay nandito, tapos yung conductance ay nandito. Tapos ito yung admittance. Ay, sorry, mali. That's wrong. Okay, dapat with respect to okay, so dapat dito pala. Okay, so ito yung susceptances, sum ng susceptance, at ito yung conductance. And then yung angle na theta is measured with respect to the positive real axis pa din. Okay? Sige, bigyan ko kayo ng 2 seconds para i-absorb yan. Okay na? Okay na? Okay. Walang tanong? Walang tanong? Okay. Siyempre, mag-ano na tayo ng example, di ba? Discuss na tayo ng example. Para makita nyo kung paano siya gamitin. So let's consider this circuit. Okay, ang circuit na ito ay may source voltage na 5 volts. At yung frequency nung input wave ay 12 kilohertz. Okay, tapos yung sino yun? 173 ba siya? Okay. Oh, sorry sa confusion sa classroom kasi tawag dito. Anyway, basta nagpalit yung previous na teachers ng classroom. Resistance is 100 ohms, inductance is 50 millihenry, at ang capacitance is 0.022. Parang mali yung units na yun. Ano ba yung nilagay dito? 0.022. Ang nilagay dito. Well, so mukhang baka micro ito, baka microfarad. Pero tignan natin sa calculations kung yan ay micro nga. So yung capacitance ay 0.022 microfarad. Ang nakalagay kasi is infinity, di ba? Nakalagay is infinite. Okay? Okay, so I think this is micro. Pero ma-verify natin yung mamaya. Okay? Okay. So, syempre ang tawag dito, ang method na gagawin natin dito, ang gagawin natin dito step by step na process ay compute muna natin yung angular na frequency. Angular frequency is just equal to 2 pi f. Yung f is 12 kilohertz. So yung angular frequency is 24 pi kilohertz. Ayos? Okay, next. Hindi ko compute na natin ngayon yung ang tawag dito? Conductance at saka yung mga susceptances. Okay, alam natin na yung conductance is just the reciprocal of the resistance. Ang resistance ay 100 ohms. So ito yung magiging sagot. Ang unit ng conductance ay Siemens. Okay? Tulad sa cellphone. Naabutan niyo ba yung cellphone na yun? I feel old. Ang next na i-compute ay inductive susceptance. Ang inductive susceptance is just 1 over omega L. Tama? Tapos ang magiging sagot dyan is 0.88 millisiemens. Okay? Now, ang susunod dito is yung capacitive susceptance. Okay, at pag in-input natin yung mga known quantities, ang makukuha natin is 1.7 millisiemens. Now, paki-verify nga kung nano siya o ano, nano siya or micro. Okay, so 24 kilohertz pi, no? Tapos 0.022 microfarad. So kilo is 10 to the minus 3, 10 to the minus 6, 10 to the 3, positive 3. 24 times 0.022. So tama pala to, micro siya. Okay, so micro. Para maging, kasi 10 to the 3, 10 to the 3. Tama no, na micro. May nag-compute ba? Wala? Okay lang. Sige. So, ano ngayon ang total na susceptance? Total na, na admittance. Okay. Ang total na admittance is just the square root of the sum of the square of G and the difference between BL at saka BC. Okay. At yung admittance ay 10 millisiemens. Ayos? Tapos, yung phase, okay, nung total na current is given by tangent inverse ng negative ng differences, negative ng sum ng susceptance, okay, divided by yung conductance. And ang makukuha niyong value dyan is 4.43. Okay, 4.43 degrees. So medyo maliit lang yon. Mukha namang maliit siya kasi kung titignan nyo rito, BL minus BC is 0.88 divided by 1.7. So 1282. Tama? 0.82 millisiemens. So ikumpara niyo yung number na yan dun sa 10 millisiemens. Diba? So maliit lang yung 0.82 millisiemens kumpara sa 10 millisiemens. So pag imagine niyo pag dinrawing niyo yung triangle, yung admittance admittance triangle, itong phasor na ito is 0.88. Tapos itong phasor na ito is 10 millisiemens. Diba? So yung angle ng admittance is very small. Right? So 4.42. So that's one way, 4.43. That's one way to check kung tama yung sagot ninyo or hindi. Or kung tama yung ginagawa nyo. Okay, so next, kukompute na natin yung currents through each of the circuit elements. First, yung ano muna? Yung magnitude muna. So yung magnitude ng source is 5 volts times 10 millisiemens. Right? Okay, yung resistor ay 5 volts times 10 millisiemens din. Okay? And then yung current through the inductor ay 5 volts times 0.88 millisiemens. So ito yung magiging sagot. And then 5 through the capacitor naman is 5 volts times 1.7 millisiemens. So ito yung magiging straightforward lang, di ba? Kaya-kaya na, di ba? Exam na. Ano na? Okay. So, syempre, isusulat niyo siya in terms of yung wave, anong tawag dito, yung equation, sinusoidal wave equation. So, alam natin na 4.43 ay yung tawag dito, angle with respect to the positive real axis, di ba? Nung total na phasor, nung admittance. Okay? So, kaya dyan siya nakalagay. Okay, tapos yung resistance, current through the resistor is just in phase with the current, with the voltage of the source, kaya wala siyang phase dito. Okay, and alam natin ang inductor ay out of phase by 90 degrees at leading, at yung capacitor ay out of phase by 90 degrees tas lag. Okay na? Okay na? Ayos. Ayos. And then finally, yung huling-huling kinumpute dito is yung total na tawag dito, reactance, impedance, total na impedance. So it's about 100, approximately 100 ohms. Okay. Makukuha niyo yan from taking the reciprocal of the admittance. Ayos. Okay. Questions? Okay. So, ang resulting na graph nito ay ganyan. Okay, so ang makikita niyo dito is yung blue ay yung resistor current. Okay? Obviously, nandoon siya sa real axis. Okay, at yung tawag dito, source current ay anong tawag dito? Yung kulay light green, yung inductor current ay andun sa positive imaginary axis at yung capacitor current ay andun sa negative imaginary axis. Okay? And ito naman yung corresponding na wave. Okay, that passes through the circuit elements. Ayos? Ayos? Okay. Ano nyo dito? Realizations nyo? Bakit hindi pa kayo nag-shift nung habang maaga pa, no? Okay. Well, ang isa nyo sigurong realization dito is, paano to ginraph? Ang ganda naman ang sulat ni Sir. Alam nyo naman kung paano ginraph yan. Tama? Tama? Imagine nyo na siguro kung anong pagiging exam ninyo, no? Ha? Ayaw mong imagine. Okay, so now let's move to the next lesson. So, balikan na lang natin yung power ng RLC circuits. Uy, ang dami yung naka-online na. Okay, now, let's consider, ngayon ay consider natin is, kung makita yung mukha ko, ano ko ba itatago? Kanina nakatago siya. Hindi na. Side by side, side by. Anyway. Nakakahiya naman sa inyo. Okay, anyway. Hindi pa din. Anyway, so now let's consider kung ano pa yung pwedeng information na pwede natin makuha from using this concept ng phasors. Okay, so consider muna natin ang isang simpler na circuit. This is an RC circuit. Okay, wala munang inductor. Okay, so it's a simple RC circuit. Dito, meron kang source na 10 volts, tapos may resistance na 56 kilo ohms, at saka may capacitance na 0.0022 microfarad. Okay? Okay, so, anong step natin dito? Anong ginagawa natin dito? So, basically, ang gusto natin mangyari dito is solve natin yung currents, diba? So, at saka yung voltages across each of the circuit elements. Okay? Ang hindi given dito ay yung frequency. Okay? Hindi binigay dito ay frequency. So, ang idea is to actually tawag dito, take a look at the frequency dependence of this circuit. So in other words, titignan natin not just one point or one single value of frequency, but titignan natin yung values for different frequencies. Okay, so ano yung mga equations na ginagamit natin dito? Paano natin masasolve muna yung tawag dito, yung so remember, ang mga given ay ito, okay, yung source, resistance, at saka capacitance. Wala nang ibang given dyan. So dapat yung expressions, okay, na i-derive natin ay involving itong tatlong quantities na ito. So to solve for the voltage across the resistor, for example, alam natin na VR, voltage across the resistor, is just equal to the current through the resistor times the resistance. Okay, yung resistance ay given. Pero yung current through the resistor, paano nyo kukunin? Well, of course, nakasulat siya dito, di ba? Pero sa tingin nyo, paano na-derive yan? Ano yan? Sa? Yes. Okay, so, na-derive siya galing dito. Okay, at yan yung equation yan. Pero, hindi ba familiar sa inyo itong process na ito? Of course, sa DC, merong ganitong equivalent, pero hindi siya square, di ba? Pero, Paano po, hindi ba pinanood yung video sa DC sources? Voltage divider. Okay, so voltage divider equation, voltage divider yan kasi 'di ba, kinukuha niyo yung voltage across the resistor. Right? Right, 'di ba? Yun naman yung lumabas dito, voltage across the resistor. So, ipapasok nyo ngayon yung current na ito dito. Okay, at makuha nyo na yung expression for V sub R. What about, ano tawag dito? Okay, ano ang problem with this equation? Ang problem with this equation ay itong V sub S. Okay? Kasi hindi natin alam alam pala natin yung source. Pero pwede natin i-eliminate yan, okay, by dividing V sub R by V sub S. So yung ginawa natin dito. So essentially, V out, which is output across the resistor, divided by the source, so V out over V in, ang lalabas is R over square root ng R squared plus 1 over 2 pi F times C. Yung 2 pi F, yun lang yung omega. And then yung 1 over omega C is just XC, right? Tama? Tama, di ba? Yung XC is just 1 over omega C. At yun yung nakasulat dito. Okay, now we have an expression, okay, that involves only the known quantities, R and C. Pero yung F, hindi siya known. Pero yun nga ang gusto natin makita dito. Titignan natin yung dependence, okay, nung expressions na ito, o nung variables na ito, with respect to F. Naintindihan nyo? Okay, so in other words, mag-graph tayo ng VR over VS versus the frequency. Yun yung i-graph natin dito. Okay, so ang tinitignan natin is frequency dependence ng mga voltages. Okay. Now, similarly, we can get the frequency dependence of the voltage across the capacitor. So ganun din. Voltage across the capacitor is just the current through the capacitor times yung capacitive reactance. And using the voltage divider technique, makukuha natin yung expression na ito. And we replace XC by 1 over omega C. At yun yung nakikita nyo dito at saka dyan. Okay? Then divide everything by Vs. Meron na kayong ganitong expression for the voltage across the capacitor involving itong frequency na ito. Okay? So objective is to graph the voltage across the resistor with respect to frequency and the voltage across the capacitor with respect to frequency. Sunod? Okay. Pag may hindi kayo naintindihan, itaas niyo yung kamay ninyo. Okay? Huwag kayong mahiya kasi tawag dito, remember, nagde-depend dyan yung grade ninyo. Pag nahiya kayo, tapos, ang tawag dito, mababa yung grade nyo sa bandang dulo, tapos magko-comment kayo na masyadong mabilis yung lesson, pero kasalanan nyo yun kasi hindi kayo nagtaas ng kamay. Right? Pero kami ang di ba? Kami yung mababang grade dahil sa kasalanan ninyo. Anyway, yung kulay pula ay VC, voltage across the capacitor, at yung blue ay voltage across the resistor. So this is the graph of, okay, yung V out of course depends on kung ano yung dito, kung resistor voltage or capacitor voltage, diba? So kung kulay blue yung V out dito is the resistor voltage, kung yung red yung tinitignan natin, yung V out is a capacitor voltage. Next na. Okay. Tapos ginraph natin siya with respect to frequency. Kasi yung frequency is from 10 to 100 kilohertz. Okay, 10 to 100 kilohertz. Anong napapansin natin dito? What is happening, for example, dun sa voltage across the resistor? Madali lang i-describe. Okay? So, i-describe nyo. Madali lang siya, di ba? So, start siya from 0, bigla siya mag-increase, and then magpa-plateau siya at some frequency, right? Then, ano naman ang nangyayari dun sa voltage across the capacitor? Start siya from a maximum value, babagsak siya, and then magpa-plateau towards 0, okay, at higher frequencies. Sunod. Now, there is an intersection between these 2 points. Okay? At yung intersection na yun ay tinatawag na cut-off frequency. Anong ibig sabihin ng cut-off frequency? Well, yung cut-off frequency is a reference frequency na kung saan anything below or above it ay mapi-filter out. Depende kung ano yung signal na pinag-uusapan. So for example, if we're looking at the blue curve, okay, so voltage across the resistor below the cutoff frequency of 1.29 kilohertz, okay, walang signal na, anong tawag dito, i-consider yung circuit. Okay? Anything above 1.29 kilohertz, okay, the voltage, yung voltage across the resistor, anong tawag dito? I-allow niya na pumasok yung signal. Okay? In contrast, the voltage across the capacitor, anything below 1.29 kilohertz ay papapasukin niya yung signal. Okay? And anything above, okay, the 1.29 kilohertz cutoff frequency ay i-reject niya yung signal. Okay? So, sa tingin niyo anong klaseng circuit ito? Ano yung ginagawa ng circuit ito? Filter, okay. Well, high pass or low pass, okay, so depende kung alin yan dyan. Pero basically, in general, nag-filter siya, tama. So, nag-filter siya ng signal. So, ang resistor, is it a high pass? Ang voltage across the resistor, is it a high pass or a low pass filter? High pass kasi high frequencies yung ina-allow niya. Okay? Na dumaan. Tapos, yung capacitor ay low pass. Okay, low pass na filter. Okay, so paano nyo, ano yan? Paano ba nag-work yan? So, di ba meron kayong circuit, nandiyan. Tapos, punong-puno siya ng mga kung ano-anong frequencies. Tapos, siyempre, gagamitan nyo yan ng filter. Di ba? Gagamitan nyo yan ng filter. Tapos, naisip nyo, ay, gusto kong i-filter out yung signals na, ano tawag dito, mas mababa, na lower frequencies. Okay, gusto kong i-filter out yung signals na lower frequencies. Okay, so, anong ilalagay natin dito? Low pass or high pass filter? If you filter out nyo yung lower frequencies, di ba? So low pass or high pass? High pass. Tama? Kasi padadaanin nyo yung high frequencies. Tama? Tama? Okay. So alin dito sa dalawa yung high pass filter? Yung sa resistor. So paano nyo ngayon i-construct yung circuit? So ang gagawin nyo is lalagay nyo yung capacitor dyan, lalagay nyo yung resistor dyan, yan yung ground, tapos dito nyo kukunin yung output. Okay? So meron na kayong high pass na filter. Sunod? Sunod? Okay. Ngayon, pag gusto nyo ng low pass na filter, anong gagawin nyo ngayon? Pag low pass na filter, tama, low pass na filter, ang gagawin nyo ngayon is, yung resistor yun nandito, yung capacitor yun nandito, ground, and then kukunin nyo yung output across the capacitor. So this is a low pass na filter. Ayos? Okay? Okay. Now, of course, ano yung, another question is, ano yung cut-off? Paano nyo i-define yung cut-off frequency? Okay, yung cut-off frequency is defined by, di ba intersection siya ng, ano ba itong graph na to? V out over V in. So essentially, impedance yan, di ba? Ratio yan ng impedances, right? So, kung saan equal yung resistance at saka yung capacitive reactance, okay, doon, yun yung point ng intersection na yan. Diba? Yung point na yan ay yung point kung saan equal yung resistance at saka yung capacitive reactance. Okay? Okay? So, dahil equal sila, okay, ang XC is just 1 over 2 pi FC, isolate niyo yung F, ang makukuha niyo ngayon is F is equal to 1 over 2 pi RC. So, yung cutoff frequency niyo ngayon is given by this expression. 1 over 2 pi RC or 1, okay, tama lang pala. 1 over 2 pi RC. Okay, now we are going to define the product of resistance and the capacitance as tau, pero alam niyo naman kung ano itong tawag dito, di ba? Tawag dito ay time constant. Wala, pag exam, si Aidan lang yung may score. Okay. Questions? Questions? Ano? Dali lang, di ba? Okay. Ano ba ito? Anong difference ito dun sa previous na graph? It's practically the same except na yung y-axis ay logarithmic scale. Okay, paano naging logarithmic scale yan? Well, yung V out over V in, kukunin niyo yung logarithm nun, then multiply niyo by 20, yan yung scale ng y-axis. Okay, so ang tawag dyan sa scale na yan is the gain. Okay, so, or signal gain. Okay? Now, makikita nyo na yung shape nung tawag dito nung filter, nag-iba rin. Diba kanina parang S shape, pero dito ngayon medyo diretso na siya and then magpa-plateau. So essentially, pag in-extend nyo yung blue line na yan, ganito yung magiging itsura. Okay, itong graph na ito. And pag in-extend nyo yung red line na yan, yung itsura niyan is pag ganyan. Okay, straight lang din yan and then magpa-plateau na flat. Okay? Pag ginraph nyo siya in terms of in a logarithmic scale. Now, nasa na ngayon yung cutoff frequency? Okay, yung cutoff frequency ay nandito. Okay, yung cutoff frequency ay nandito dyan. Okay, tignan nyo kung ano yung value niya sa y-axis. Nakikita nyo ba? Yan. Yung value niya sa y-axis ay negative 3. Negative 3 decibels. Negative 3 dB. Okay? So, kung yung tawag dito, kung yung axis na pinakita sa inyo is logarithmic axis, para makita niyo yung cutoff frequency, hanapin niyo kung nasa negative 3 dB. Okay, kasi yung negative 3 dB, yung corresponding na tawag dito, point para sa cutoff frequency. Okay, so may logarithmic scale kayo dito. Hanapin nyo kung nasa yung negative 3 dB. Tapos i-project nyo sa F, sa x-axis scale, yun yung cutoff na frequency. Okay? Now, in some graphs, hindi talaga zero ito. Minsan, ano siya, minsan iba ang value niya. Halimbawa, negative 1. So, gagawin nyo, magbibilang lang kayo ng negative 3 pababa. Okay? Halimbawa, hindi ito 0. Halimbawa, ang value niya is negative 1 dB. So, hanapin niyo yung negative 4 dB. Okay? Para makuha yung cutoff na frequency. Okay? Okay? Okay. So, this is another way to represent ano tawag dito, frequency dependence. Okay. Now, ano yung ibig sabihin ng 20 doon sa gain? Yan, ano yung ibig sabihin ng 20 dyan sa gain? Oops. Keep. Okay, ang ibig sabihin ng 20 dyan sa gain is this. So this is 1 decade. Ano ibig sabihin ng 1 decade? From 10 to the first power to 10 to the second power. Diba kasi naka-logarithmic scale siya? Yun yung isang decade. Okay? Okay. Tapos, pag binilang niyo yung rise, that corresponds to exactly 20 decibels. Okay, doon yung makikita yung 20 na. Okay? So, in fact, hindi nyo kailangan tawag dito, tawag dito. Pwede kayong mag-graph by hand. Right? Kasi ang gagawin nyo lang is, bibilangin nyo yung per decade, tapos bawat decade ay 20 decibels. Ang rise. Ayos? Ayos? Okay. Now, pinag-usapan natin yung voltage across o yung voltage out divided by voltage in. What about yung phase? Okay, tignan naman natin yung graph dito sa dito sa baba. Ano nangyayari dun sa phase? Ano ang frequency dependence ng phase? Ang frequency dependence ng phase, ganito yung itsura. Okay, start siya sa 90, then bababa siya, katulad nito, and then dire-diretso siya magpa-plateau hanggang sa 0. Okay, sa 0 degrees. Yung cutoff frequency is at 45 degrees na phase. Naintindihan niyo kung bakit 45 degrees yung cutoff frequency o hindi? Meron ba makakahula? Mahulaan niyo ba kung bakit nasa 45 degrees yung cutoff frequency? Bakit? Paano niyo ba kinompute yung cutoff frequency in the first place? Paano ba natin kinompute kanina yung cutoff frequency? Ha? Intersection. Pero numerically, ano yung basis natin? Anong variables? Yung equation. Equation na pinapasayan. Equal yung resistance at saka positive reactance. Pag dinrawing yung impedance line, gano'n ang itsura. Yes, di ba? Kasi equal kasi yung x-axis at saka yung y-axis. So, ang phase angle niya is 45 degrees. Kaya 45 degrees yung dyan. Right? Okay. Now, ang tinitignan natin dito yung kulay blue. So, ibig sabihin, this is a low-pass filter. Pag low-pass filter, ano yung zero? Yung voltage across the resistor o yung voltage across the capacitor? Voltage across the resistor, di ba? So dahil zero yung voltage across the resistor, maximum yung voltage across the capacitor. So sa phase argon diagram, anong itsura ng phasor? Zero yung VR, wala kang VR, so ang meron ka lang is DC. So ano yung itsura ng phasor? Arrow lang siya pointing upward, di ba? Ano ang phase angle? 90 with respect to the real axis, di ba? 90 degrees. Kaya 90 yung nakasulat doon. Tama? And then, pagdating dyan, maximum na yung voltage across the tawag dito, resistor. Wala kang voltage across the capacitor. So ano yung phase angle of that is? Zero. Diba? Kasi yung phasor nyo nandun na sa real axis. Wala kang phasor sa imaginary axis kasi zero nga yung capacitor voltage. Right? Right? So zero yung phasor. Okay, naintindihan nyo kung bakit ganyan yan? Okay. Okay. Ano? Kaya na. Ba't pag binibigyan ko kayo ng positive na tinatawanan nyo lang ang sarili ninyo? Dapat mahawa kayo dun sa positive vibes. Okay, ano ba tong graph na ito? Yung phase angle. Okay, so this is the phase angle plotted with respect to frequency. At makikita nyo na yung 45 degree tawag dito would correspond to 1.29 kilohertz. Okay. Questions so far? Questions? Okay, so paano natin i-summarize ito ngayon? Yung frequency dependence nung phasor diagram. Yung phasor ng RC na nasa. Malis kayo dyan! Ay, kasawa din. Ilan na yung i-edit ko? 3 na, no? Ano? Wag ko na i-edit para habang nanonood kayo, di ba? Sabihan niyo yung tignan, pakinggan niyo ito, pakinggan niyo ito. Yung pala kasi yung roommate niyo nasisigawan. Ano? Okay, anyway. So paano natin sa-summarize dito ngayon yung frequency dependence ng phasor ng RC na circuit. So nakita natin na anong tawag dito? Pag nag-increase yung pag resistor voltage na. Pag resistance. Ano nangyayari sa resistance habang nag-increase yung frequency? Tumataas yung resistance, di ba? Tumataas yung resistance. And yung capacitive reactance ay bumababa. Okay? So yung resistance is dependent on the frequency, parang inversely, pero not necessarily inverse, di ba? So pag tumataas lang yung resistance, or habang lumalaki yung frequency, tumataas yung resistance. The same way, yung capacitive reactance, habang lumalaki yung capacitive reactance, bumababa naman yung frequency. Or pag bumababa yung frequency, tumataas yung capacitive reactance. Okay? Ganon din yung phase angle. Right? Right? Okay. Okay, so yun yung summary para dyan. Hindi, alam nyo na kung paano i-handle ito ngayon. Siya lang tumawa. Napakaseryoso nyo ngayong araw. Ba't di kayo ganyan last time? Okay. Mahuhulaan nyo ba sa tingin nyo kung alin dito yung high pass at saka low pass na filter? So, in other words, pag kinuha ko yung voltage across the resistor, will it give me a high pass or a low pass filter? Pag kinuha ko yung voltage across the inductor, will it give me a high pass or low pass filter? Ano sa tingin nyo? Well, itong tignan nyo, ayan. Itong pagbasehan yung dalawang equations. Yung iba, tinitignan na yung notes na na-download na nila sa BLE. Guess lang naman. Guess lang. Sa tingin nyo. High pass filter yung alin? Resistor. Tapos yung inductor ay low pass filter. Tama ba kayo o mali? Okay lang yan. Learning experience, di ba? Learning experience. Hindi pa naman to graded. So okay lang yan. Okay? Now, anong tawag dito? Concept is basically the same thing as the RC circuit. Diba? Yun lang, baliktad pag RL. Pababa naman yung resistor voltage as the frequency increases. Tapos, yung inductor voltage ay pataas habang nag-increase din yung frequency. Okay? Okay? Ganon din yung resistance. So yung resistance pababa with increasing frequency, and then yung capacitive inductive reactance ay paakyat din with frequency. Yung cutoff frequency is also computed the same way. Equate nyo lang yung resistance with the inductive reactance. Okay, ito makakuha nyo yung cutoff frequency. So ito yung cutoff frequency for the RL circuit. Ayos? Okay. Now, yung time constant is defined a little bit differently. Pero napag-aralan nyo na rin ito sa 102. Right? So 102, ang time constant is just the ratio of the inductance at saka ng resistance. Okay, RL circuit ito RL circuit. Okay, in terms of ano tawag dito, logarithmic scale, okay, ganito yung itsura niya. So basically the same sa RLC circuit except na yung R pababa as frequency increases, and yung inductive reactance, capacitive reactance ay paakyat as frequency increases. Pero yung phase shift, gano'n na gano'n din. Right? So at 45 degrees, dun yung makikita yung cut-off frequency. Right? Right? Okay. So, anong nakuha natin dito? Nakuha natin dito, basically, yung XL increases with frequency. Okay, and yung phase angle also increases with frequency sa RL circuit. Ano? Ito na yata yung pinakamahabang 1.5 oras ninyo, no? Wala pa nga 1.5 oras. Pero pag exam, paikli, no? Okay. Pag-usapan natin later yung schedule ng exam kasi baka mabitin kayo sa 1.5 oras, no? Di tayo pwede mag-extend kasi may klase, may class. Okay. Now, pwede natin i-graph yung behavior ng tawag dito ng mga circuit elements na yan or behavior ng capacitive at inductive reactances as a function of frequency. So ito yung graph na yan. Okay, so nakita natin na yung inductive reactance is actually linear with respect to frequency. Okay, so natin makikita na linear siya with respect to frequency. Hindi pala natin kailangan kasi isusulat lang natin, di ba? Linear siya with respect to frequency, right? And yung capacitive reactance is just inverse nung frequency. So pag ginraph natin yung reactances in terms of frequency, itong curve na ito, okay? Yan yung curve na nag-describe ng capacitive reactance versus frequency. Okay, that's the 1/f curve. Okay? At itong curve na to is the linear curve that describes yung dependence ng inductive reactance sa frequency. Okay? At meron silang intersection. Okay? At yung intersection nila ay yung frequency corresponding to resonance. So it's a resonant frequency. Narinig nyo lang resonant frequency, di ba? O hindi pa? Narinig nyo na bang resonant frequency? Sa sound. Okay. So what about anong tawag dito? Anong nangyayari pag yung sound ay nagre-resonate or in resonance? Ha? Ano yun? Ako magtatanong pero ang sasagot ninyo, pag sumasagot kayo, kausap nyo sarili ninyo. Di ba? May problema doon . Yes, exactly. Nag-interfere constructively or destructively yung waves. Okay? Pero dito, ang pinag-usapan nating waves dito ay sinusoidal na waves, yung signal, right? So, bawat wave na yun ay merong frequency. And it just so happened that pag yung dalawang waves na yun ay in sync or in resonance, okay, nagre-resonate sila and yung frequency na yun ay tinatawag natin resonant frequency. Now, makikita nyo rin dito, pag equal yung XL at saka XC, anong itsura nung phasor sa imaginary axis? Equal ang XL at saka ang XC. Equal sila. So, 0, di ba? Wala kang phasor, right? Di ba? So, ang total na phasor nyo is just purely due to resistance. Tama? So, pwede natin actually i-drawing dito yung resistance kasi ang resistance walang dependence sa frequency eh. Di ba? So, at the point na kung saan pinakamaliit or point kung saan equal yung XL at saka XC, anong tawag dito? Ang nagdo-dominate ay resistance. Sunod. Okay. Okay. So bakit natin pinag-uusapan ito? Kasi kung titignan niyo, kinumbine na natin yung inductor at saka yung capacitor. Diba? Tinignan natin yung behavior ng both inductor at saka capacitor. Nakita natin na pag magkakasama na silang lahat, yung tatlo, yung frequency dependence ng RLC, series RLC circuit, will be will be based on this type of behavior. So at frequencies lower than the resonant frequency, dominant yung anong tawag dito? Ano ang dominant? XC or XL? Frequencies below XC, di ba? Obviously XC. So dominant ang XC. Tapos, at frequencies above the resonant frequencies, XL. Okay? So pag kinumbay natin yung graph na yan, magiging itsura ng graph. Ayan. So yung red na graph ay yung Z, which is nothing but R squared plus XL minus XC squared. Okay? Okay, so ganyan yung itsura nung. So yung minimum value dito corresponds to, yung minimum value dyan corresponds to the resistance. Okay, so dapat dito siya. Okay, corresponds to the resistance. Okay? Okay, so ito na yung ating series na RLC circuit. Okay, yung expression sa taas ay yung total na impedance. Yung nandito sa graph, yung kulay pula, yan yung XL versus F. Yung blue, yan yung anong tawag dito? XC versus F. At yung pink or fuchsia. Pink na lang kasi mas madaling i-spell. Pakaluma ng joke na yun. Minimum siya at minimum yung pink na curve at what expression or what quantity? At the vertical frequency, pero yung ano yung value ng kanyang reactance? Yung kulay pink. Yung minimum value ng reactance. Equal sa? Hindi zero. Nakasabi lang natin kanina eh. Ano yung matitira pag wala? Pag walang ano? Pag nag-cancel out ang XL tsaka ang XC, anong matitira? So minimum value ng pink na curve na yan ay resistance. Diba? Diba? Resistance. Diba? Kasi wala nga to eh. Zero nga siya eh. Diba? So yung impedance ay equal lang sa resistance. Nakalagay dyan XR, pero yung XR is just the resistance. Okay? Okay, now, paano niyo i-compute yung resonant frequency? Ang resonant frequency is when, paano na-compute yan sa tingin niyo? Hindi ko ata nilagay pala yan. Ito pala, nilagay ko dito. Ang resonant frequency is when XC ay equal sa XL. Ang XC is 1 over 2 pi FC at ang XL is 2 pi FL. Right? So solve for F. Kaya ito makukuha yung expression for resonant frequency is 1 over 2 pi square root ng product ng inductance at saka ng capacitance. Ayos? Ayos? Okay, in this case, this example na to, ang resonant frequency is 24 kHz. Naintindihan nyo naman kung paano nakuha yan, di ba? 1 over 2 pi times square root ng inductance, which is 2 millihertz times the capacitance, which is 0.022 microfarad. Konti na lang. Okay. Shit, ano yan? Tignan nyo muna yung colors. Black is for current. Pink is the resistor voltage. Red is the inductor voltage. Okay, blue is the capacitor voltage. At yung green ay combined na LC. Okay? Voltages din yan. So voltage. Okay, so tignan na natin ngayon yung graph. Okay, yung current, nasaan yung current? Kulay black. So may peak siya, nagpi-peak yung current at the resonant frequency. Naintindihan? Bakit nagpi-peak yung current? Pipeak yung current at the resonant frequency. Maximum yung current at the resonant frequency. Obviously yung pinakamalakas kasi nag-peak na siya, di ba? Pero bakit siya yung pinakamalakas? Nawawala yung wala, di ba? Equal, nag-cancel out yung XL at saka yung XC. So ang natira ay resistance. So originally tatlo yung tawag dito resistances, di ba? Reactances. Pero nawala yung dalawa. So naging minimum yung reactance. So magiging maximum na yung current. Tama? Okay, in the same way, magiging maximum din yung resistor voltage. Actually, lahat yan magiging maximum. I mean, makukuha nila yung maximum value nila at the resonant frequency. So yung sharpest point ay nandun sa resonant frequency. Now, yung combined LC, of course, yan yung lowest point naman nila. Naintindihan nyo naman kung bakit yan yung lowest point, di ba? Kasi exactly, di ba? Zero nga siya, di ba? LC combined, zero nga yung value niya. So, minimum value nito ay zero. Tama? Tama? Okay, now, this is a graph of the current or voltage with respect to frequency. Kanina, ang pinapakita nating graph ay voltage ng R versus frequency, voltage ng C versus frequency, right? And we're actually looking at the same thing here. Voltage to ng resistor versus frequency. Di ba yung kulay pink? Voltage ng inductor, yung kulay red versus frequency. Di ba? So anong napapansin nyo? Nag-filter out ba siya ng signal o hindi? So halimbawa, tawag dito, nagpadaan ako ng tawag dito ng signal sa isang circuit. Okay. Would this type of circuit, RLC series, give me some sort of filter or hindi? Yes, sir. Anong klaseng filter? Tingin niyo? Yes, so meron na siyang specific na range kung saan i-filter niya yung signal. Anything below that range ay wala or i-reject niya. Okay? So may band lang of frequencies na inaalaw. So this is called a band pass filter. Okay? Band pass. Yeah, band pass filter. O, paano kayo mag-create ng band pass na filter? Siyempre, kailangan nyo ng cut-off frequencies dyan. Right? Pero yung cut-off frequencies niyo dalawa. Dalawa yung cut-off frequencies. Okay? So, in this particular example, yung resonant frequency ay 24 kHz at yung cut-off frequencies, sabi ko sa inyo, dalawa. May dalawang points, F1 at saka F2. Okay? And yung difference between F2 at saka F1, F2 minus F1, ay tinatawag na band width. Okay? Or BW. So yun lang yung width of frequencies na inaalaw niya na pumasok. Or nire-reject niya na pumasok. Depende kung saan nyo tinitignan. Okay? Kung anong tinitignan ninyo. Now, anong tawag dito? Kung yung output, so halimbawa meron akong circuit dito. Okay? Tapos pinadaan ko siya sa ganitong RLC circuit. Okay? Pinadaan ko siya sa RLC circuit na yan. Tapos kinuha ko yung output across the resistor. Kinuha ko yung output across the resistor. Is this a, ano sa tingin nyo? Is this a, well, mag-act siya as a filter, pero, yung kulay pink ba siya o yung kulay green? Kasi yung difference between yung kulay pink, sa kulay pink, papadaanin niya lang itong range na ito. Everything outside the cutoff frequencies, reject niya. Pero yung kulay green, hindi niya papadaanin itong range na ito. Diba? Intindihan niyo? Tapos, yun yung papadaanin niya yung sa outside of the cutoff frequencies. Okay? So, yung kulay pink ba dyan ay pag measure natin yung voltage across the resistor or pag measure natin yung voltage across both the L and C? Ano sa tingin nyo? Ano ba itong ano na to? Ano ba itong voltage na ano to? Saan nyo i-measure yung output? Sa resistance. Diba? Okay. Pag measure nyo yung output across the resistor, you're measuring the voltage across the resistor. Okay? At meron kayong bandpass na filter. Yung kulay pink. Okay? Okay? Pero, pag measure nyo yung voltage across LC, okay, ito yung meron kayo. So, i-reject nyo yung, it's a filter that rejects yung maliit na band. Pero, hindi nyo ginagamit yung filter na yun kasi, anong purpose na, diba? Okay. Now, anong silbi yung bandpass na filter? Sa tingin nyo, saan nyo nararanasan yung bandpass na filter? Yeah, exactly, sa radyo. Okay. Paano yung ginagamit sa radyo? Kasi tinutune nyo siya, di ba? Yes, yung frequency na desired nyo ay tinatawag natin na anong paborito yung radio station kung nakikinig kayo sa radyo? FM. So, anong frequency ng FM? 97. Hindi. So, hindi nyo paborito kasi. Hindi nyo alam yung value. Anong, mag-ilan din yung number ng isang radio station? 92, 96, 92, 93.1. Megahertz yun, di ba? Pag FM? So, pag FM 9 megahertz, 93.1 megahertz, right? Ano yung 93.1 megahertz na yun? Base dito sa mga pinag-uusapan natin. Anong variable siya? Oh, frequency nga siya. Pero daming iba't ibang frequencies na diniscuss dito, di ba? Cut-off, resonance, di ba? Ano siya doon? Siya yung resonance frequency. Diba? So yung rate, pag nag-tune kayo sa radyo, ang tune nyo is yung resonance na frequency. So ang ginagawa nyo, pag nag-tune kayo, binabago nyo yung values ng capacitor at inductor. So dun sa circuit elements, may variable inductor at may variable capacitor. So babaguhin nyo yun hanggang sa maging, ang tawag dito, minimum. So nangyayari, nag-move yung wave. So pag tune nyo, sa isang frequency, nandiyan siya. And pag ni-retune nyo, nandiyan siya. Pag ni-retune nyo, nandiyan siya. Ito yung frequency ng LC. Okay? So, nag-move yung resonant na frequency. Okay? Isang pang example. Itong resonance RLC. Sa Wi-Fi. Pero ang Wi-Fi is more specific. Diba? Pero nakaset na yun. Dun sa router yun, nakaset na siya. So, ibig sabihin, meron kang dalawang sets ng ano tawag dito, RLC na circuit. Of course, hindi siya simple RLC lang talaga. Pero at least, yung basic RLC na concept na doon sa circuit. So, any device na kung saan gusto nyo set yung frequency, you use a RLC circuit. Okay? You can tune it para maging variable, or you can fix it para iisa lang talaga yung padadaanin niya na frequency. Ayos? Ayos? Okay, so hindi ko na-discuss yung yung power. It's just a small, just a few slides. Naka-upload naman na yung video dun sa ano tawag dito, dun sa VLE. So, pag-aralan nyo na lang yung video para ano natin yung, or para maintindihan nyo kung ano yung power of each of that. Okay? Now, anong gagawin natin next week? Ano naka-schedule next week?